Hello, algebra students. As we talked about earlier, when I was a freshman, one of the questions on a test that I took called the NEDT was to sum all the digits between 1 and 100. And if we tried to do that by hand, we'd be taking a long time. But if I can see a pattern where if I have 1, 2, 3 on one end, and I have 98, 99, and 100 on the other end, and I start pairing them up, 1 with 100, 2 with 99, 3 with 98, you'll start to see that each sum is 101. And so the question becomes, how many sums do we have? Well, if we get down to the middle where we have 50 and 51, and I count kind of the first digit and figure out how many there are 50 sums. And 101 times 50 is 50/50, and that would be the sum of all the digits between 1 and 100. I could actually denote that as S of 100. The formula for this is pretty simple, and I can generalize it right now. S of n for an arithmetic sequence is equal to, we have kind of this sum is created by doing the first term, and we'll denote that t of 1, plus the nth term, if I'm taking the sum of the first n terms. So in this case it was the 100th term, which was 100. We'll call that t of n. So the first term plus the last term, and then we're going to kind of multiply that by the number of terms divided by 2, since they're paired. So this is the third formula that you really need to memorize. S of n is equal to n over 2 times t of 1 plus t of n. So this is essentially the formula that we really have to work with, and we're going to practice some examples now. Number 1, if the first term, t of 1, is 57, and the unknown nth term is 177, find the sum of the sequence when that particular term happens to be the 12th term. So I could actually rewrite this as t of 12 is equal to 177. And then I can say, well, we're actually trying to find S of 12. I want this S of the 12th term. So this is kind of a simple plug and chug now. S of 12 is 12 over 2 times 57 plus 177. And if you work that out, you get 6 times, that would be 234, which is 1044. Just kidding, that was me looking at my wrong notes. Let's do 234 times 6 really quick off to the side, since it takes less time than it does to pull your calculator out. There we go, 1404. That looks better. Okay, let's erase that to make it look clean, and kind of move on. Sorry for all the space. Number 2, let's find the sum of this sequence. Okay, so if I do my S formula, and I realize that I have S of n, I right away realize I'm missing n. I know 52 is t of 1, and negative 17 I could call t of n. I just don't know what the n is that goes with that. So we have to go back to a previous formula. T of n is equal to t of 1 plus n minus 1 times the common difference in order to figure out what is the n associated with negative 17. Negative 17 equals 52 plus n minus 1, and the common difference here, it looks to be negative 3, since I'm subtracting 3 to get to the next term. So subtract and solve, I have negative 69 equals n minus 1 times negative 3. Let's divide by negative 3, and I have 23 is equal to n minus 1, or n is equal to 24. So I can kind of cut that out and say, well, I now know that I'm doing S of 24. I'm doing the first 24 terms, because I'm pretty confident now that negative 17 is the 20th term, or 24th term. So then 24 over 2 times 52 plus negative 17. And that simplifies to 12 times, that would be 35. And 12 times 35 is 420. Okay, number 3. Find the sum of the first 100 odd digits after 48. Well, the sum of the first 100, I know I'm actually going to be adding up 100 things, so I'm looking for an S of 100, and I know that after 48, 49 is the first odd digit, so T of 1 is 49. Other than that, for the formula, I have to know what T of 100 is. So let's use the T of 100 is equal to T of 1 plus 100 minus 1 times the common difference. Well, if they're odd digits, the common difference would have to be 2. 49 plus 99 times 2 is 198. And that would be 247. So if I kind of go back to this, I would say S of 100 is equal to 100 over 2 times the first one is 49, the 100th one is 247. That's equal to 50 times, this would be 296. And 50 times 296 is 14800. Okay, number 4. First 1,000 multiples of 11 after 35. Well, I love this after 35 because my T of 1 is not 35. It's the first multiple of 11 after 35. That should be 44. And to get to the next one, we'd have to add 11, so difference is 11. And I want in n of 100 or 1,000, so I'm actually looking for S 1,000, which means I'm looking for T of 1,000. Well, T of 1,000 is equal to T of 1 plus 1,000 minus 1 times the common difference, which is 11. Okay, simplifying this in my head, I'm actually going to use the distributive property here. I'm going to say plus 11,000 minus 11, because then I can combine the 44 and the 11 to get 33, and I know that 11033 is the sum, and I didn't even have to pull out a calculator for that. S1000 is equal to n over 2, so 1,000 over 2 times T of 1 is 44, T of 1,000 is 11033. You will want to break out your calculators for this one. I can get it down to 500 times 11077. But let's be honest, after that point, we can just break out the calcs and say 5,538 and 500. Please put commas on a number that big. And that's my sum. Let's go to number 5. We have sigma notation. If I write this in expanded form, like we practiced on the previous homework, my expanded form would say this is 4 times 2 minus 2. Plus 4 times 3 minus 2 plus dot 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 all the way up to 4 times 11 minus 2. Well, this is T of 1, but I don't want to call it T of 1. It's not really kind of true-ish, but let's sort of put, okay, 4 times 2 minus 1, this is 6. 4 times 12 minus 1 is 10, and 4 times 11 minus 1 is 42. Okay. Let's kind of rewrite this formula here just a little bit, because I want to make sure the notation is correct. The sum of an arithmetic sequence... Ooh, how do I know it's arithmetic? Should I do one more term in here? Maybe. If I do 4 times 4 minus 2, I get 16 minus 2, or 14. Okay, it's arithmetic. They're adding 4 every time. Another way you can tell it's arithmetic, and you should be able to tell it's arithmetic, is if you look at this particular type of equation is linear, with the slope equal to 4, which is also equal to a common difference of 4. So, back to our initial problem though, if I want to do the sum, arithmetic sum, S of n, I can say it's equal to the number of terms over 2 times the first term plus the last. That's really what's going on. So I'm going to sort of not use variables here, I'm going to use words. I'm going to say the number of terms here, like we said previously, that's equal to the upper limit minus the lower limit, but then plus 1. And we talked a lot about why that is so. If I do 11 minus 2, I get 9, but I have to add 1 to account for the fact that I'm using both 11 and 2. Count the digits. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 digits, 10 digits if I count 2 and I count 11. So my number of terms is 10. The first term is equal to 6, and the last term we said was 42. So my sum would be equal to the number of terms, 10 over 2, times 6 plus 42. And I would get 5 times 48, and 5 times 48 is, 5 times 4 is 20, 5 times 40, okay, so 240. A game store employee decides to create a display of rows with Wii U games on the top of each other in 10 levels. Each level has 7 fewer games than the one before it. The top level has the fourth best-selling games. So if the top one has 4, T of 1 is 4. The next one, let's just kind of sketch this out. The next one has 7 more because each row has 7 fewer than the one below it. So the one below it has 7 more. So we have 4, then it has 18, and it's doing this for 10 levels. That's a lot. I don't know, some crazy pyramid thing they're doing. So T of 1 is 4, not 1. We want 10 levels, and so I want to figure out what T of 10 is. I want to figure out how many games are on that 10th level. But I also know that the common difference, I'm adding 4 every time to generate this sequence. 4, 11, 18, common difference is 7. And I want to figure out how many total games there are on the display, so I'm actually looking for S of 10. So I don't know T of 10, I don't know S of 10. Let's do T of 10 first, since I need it for S of 10. T of 10 is equal to T of 1 plus 10 minus 1 times 7. 9 times 7 is 36, plus 4 is 40. 40 games on that bottom row. So then we do S of 10 is equal to 10 over 2. T of 1 is 4. T of 10 is 40. And I have 5 times 44, which is 2020. Or 220, or 220. You know what I mean. Plus 10 minus 1 times the common difference is 7. So we have 63 plus 4 is 67. Then we do our formula. S of 10 is equal to 10 over 2. T of 1 is 4. T of 10, the 10th term is 67, T of 10. And we get 5 times 71, which is 355. And since this is a word problem, I could say there are 355 games in the display. Okay, number 7. First 3 terms of the arithmetic sequence, and it gives me the sum. Okay. S of n, we don't know what the n is on this, but it tells me what the sum is. We need to figure out what the n is. Let's just use the Sn equation. S of n is equal to n over 2 times t of 1 plus t of n. And I'm actually solving for n here. I want to figure out how many terms there are. So let's do 1050 is equal to n over 2 times 5 plus 100. And see, if I multiply both sides by 2, I get 2100 equals, and this would be 105n. So that would be, what, 20? N is equal to 20, yep. Okay, first 3 terms. Well, then we need to figure out what the common difference is. So I'm going to go to my t of n equation. I can now call this safely t of 20 is equal to 100. So 100 is equal to t of 1 plus 20 minus 1 times the common difference. So I would get 95 is equal to 19d, and that would be d is equal to 5. So finally, first 3 terms, I know t of 1 is 5, so t of 2, oops, I apologize. T of 2 would have to be equal to 10, and t of 3 would have to be equal to 15. Okay, take a pause. We're going to come back in just a second with geometric series. And we're back with just a little space at the bottom to talk about geometric series. Geometric series is a different formula. It's a little bit more difficult to memorize, so I want to assure you that you won't actually have to derive this, but you do need to know what it is, and you're going to work with this a lot. We're going to start with just the formula right now. S of n is equal to t of 1 minus r to the n over 1 minus r. And this will never ever work if r is not, or is r is equal to 1, so we have to say r is not equal to 1 as a domain restriction on this thing. If you're interested in seeing the derivation, I can do it. I'm probably going to do it in class if we have time. But for the interest of kind of saving time on this video and getting to some real problems and applications, we're not. The derivation of this is in your book, not the scanned one, but your actual book. And so you're welcome to look it up in section 11.5 to see where this formula came from. I know some of you might be a little curious and not wanting to take my word on this one. But let's kind of take this formula and bring it down here. S of n is equal to t of 1 times 1 minus r to the nth power over 1 minus r. Number 8, we're going to evaluate this particular one. Now, if I look at this and I see the formula after, remember this part represents the formula, I see a variable in the exponent, which means geometric sequence. It also means that this formula matches my formula for geometric sequence, t of 1 times r raised to the n minus 1. From that, I could actually pull apart that t of 1 is 3, r is negative 2. But if we didn't, and I wanted to, I could plug in n equals 1. And if I plugged in n equals 1, I get 3 times negative 2 to the 0th power. Then if I plugged in n equals 2, I get 3 times negative 2 to the first power. And if I plugged in 2, I get 3 times negative 2, or sorry, 3 times negative 2 to the second power. So this would be 3, and this would be negative 6, and then this would be positive 12. So clearly I can see that my r is in fact negative 2 if I couldn't get it from just looking at the equation. You can always start subbing numbers in. So what does this particular equation require? It requires that I know what t of 1 is. Okay, t of 1 is 3. I know r is negative 2. And then it wants to know what n is. It wants to know how many terms we're adding. Well, if I'm going from a lower limit of 1 and an upper limit of 10, I know the number of terms is 10 minus 1 plus 1, or 10. Which should make sense going from 1 to 10. So we're actually trying to find then s of 10, the sum of 10 terms. T of 1, 1 minus r to the nth power, n is 10, over 1 minus r. Parentheses are really important here. Okay, now let's follow this. We got 3 in front. 1 minus, order of operations says negative 2 to the 10th power. We told a few days ago that 2 to the 10th you should memorize is 1024, 1024. 2 to the 10, 1024. 1 minus 1024 over, then I have 1 plus 2. 3's are going to cancel, and I get 1 minus 124, or negative 1023 for my sum. Number 9, find the sum of the geometric series with 10 terms. Hey, that means s of 10. Where the first term, hey, that means t of 1 is 1/4. Is that in a common ratio? Hey, that means r. Okay, a little bit more practice. S of 10 is equal to t of 1 is 1/4. 1 minus r to the 10th power over 1 minus r. Well, radical 2 to the 10th power, that should be the same thing as radical 2 to the 10th like this, which is 2 to the 5th power. So that's just 1 minus 32. So let's simplify that. I'm going to move this off over here. We go 1/4 over 1 minus 32 over 1 minus this. Okay, let's simplify this just a little bit. Let's make this 4. Let's bring this to the denominator. I can actually multiply the numerator and denominator by a 4, or just bring the 4 and the 1/4 down. We're going to make this negative 31 It's now a prime number over 4 times 1 minus radical 2. And I'm going to rationalize multiplying by 1 plus radical 2. Then I have negative 31 times 1 plus radical 2 over, and this would be 4 times 1 minus radical 2 is 1 minus 2, which is negative 1. So my final could look like 31 times 1 minus root 2 over 4. I could distribute the 31 in, but I'm just going to leave it factored. Fabrizio family paid $900 for electricity during 2005. Their cost increased by 10% each year. Well, in T of 1, in year 1, they paid $900. Costs increased by 10% means that my R value, I don't want to make it 10% because that would make it less per year. I want to make it 110%, or 1.1. We've seen that before where we use a value larger than 1 to make it an increase rather than a decrease. So T of 1 is 900, R is 1.1, and I'm looking for the sum of how many years are there between 2005 and 2010. There's actually 6 years if we include 2005 and 2010. So S of 6, I'm looking for T of 1 is 900, 1 minus 1.1 to the 6th over 1 minus 1.1. For this, I'm going to break out the calculator. And resuming, you see I can enter. I've entered this. Press enter, and I get 6944.05. $. And that's it.